Now let's see the length of major axis and minor axis. As we have two cases here of the ellipse, which is in this form, and here the ellipse which is in this form, we see that these two are the cases here with a greater than b and this with a less than b. So with these two cases of a greater than b and a less than b, we have two types of ellipses, one in this form and one in this form. So here, as we have seen clearly that this is a dash and b dash, and similarly out here. Now here the major axis is x-axis, as we all know, because it makes the major segment of the ellipse, and here this is the minor axis, since this makes the minor segment of the ellipse. But as you see in this case, this makes the major segment, so major axis is along y-axis. Therefore, in case of a less than b, the y-axis acts as the major axis and this acts as the minor axis. So in this case of major axis, we have length of major axis, which is given by the length of a dash, that is nothing but 2a, and this is 2b. Is 2a, and length of minor axis is bb dash, which is 2b, is what we get as major axis and minor axis. But as I see here, my major axis is bb dash, so my major axis is 2b and my minor axis as 2a. Clearly I can see my length of major axis is bb dash, which is 2b, and my length of minor axis, which is a dash, is 2a. Is how the whole of the concepts change with the a greater than b and a less than b. So length of major axis is 2a and length of minor axis is 2b, but in this case length of major axis is 2b and length of minor axis is 2a, because a is less than b and a is greater than b. And here the major axis is along x-axis and minor axis along y-axis, but in case of a less than b, the minor axis is along x-axis and major axis along y-axis. Now let's see the equation of ellipse with center as hk, that is, the center is non-origin. So in this case, clearly I see that the center, which is origin, is transformed to this. So let's take the transformed equation of the original standard of ellipse. So in order to do that, we always need to understand the standard form of ellipse as compared with the transformed equation of ellipse. Say for example, I have for a greater than b, if suppose my equation of ellipse in the standard form is x squared by a squared plus y squared by b squared equal to 1. Equation of this kind of ellipse is given by this. and this here, the center is origin, and the focus is A comma 0, and S dash is minus A comma 0, and my A is A0, and my A dash is minus A0, B is 0B, and my B dash is 0 minus B, and my directrix, which gives Z as minus A by E comma 0 with Z dash, and here my Z is A by E comma 0, and the equation of directrix is x equals minus A by E, and this is x equals A by E. Is how we get each of the contents of this kind of an ellipse. Now let's compare this with the transformed equation. If the center origin is transformed to say the new equation, that is hk, then this center transformed to hk makes us understand that equation of the transformed equation is x minus h whole square by a square equal to 1. So this is the equation of transformed equation of ellipse, where I have my capital X as x minus h and my capital Y as y minus k. So each of the coordinates, the new coordinates of this standard form of ellipse, is obtained when I replace the x with x coordinate and y with y coordinate. Say for example, I want to find the new center for this ellipse, then my x coordinate of the original center is replaced with x equal to 0 and y equal to 0, because x coordinate is 0 and y coordinate is 0. So to find center, I have a greater than b, and to find center I just take x equal to 0 and y equal to 0, and therefore I get capital X, which is x minus h, equals 0 and y minus k equals 0. That implies x is h and y is k. Therefore with x equal to h and y equal to k, I get my center as hk. That is, the new center for the transformed equation of this is hk. Is how we find each of the contents, with center being hk for this equation. Now let's find the focus S for the new transformed equation using the standard form of the ellipse. The focus S AE comma 0 when transformed is obtained by taking x equal to AE and y equal to 0, where my x is x minus h equals AE and my y minus k is 0. Therefore I get my new coordinates as x equals AE plus h and y equal to k. Therefore the focus, the new transformed focus, is AE plus h comma k. Similarly, my S dash will be minus AE plus h comma k, is what I get for the new coordinates of the transformed equation of ellipse. Now next, to find the directrices L and L dash. So to find the directress L and L dash, I have my equation of directrices x equal to A by E, that is x equals A by E and x equals minus A by E. Therefore the new directrices would be, by taking x minus h is A by E, therefore equations of directrices is x equals h plus or minus a by e is what we get as the new directrices for the transformed equations. X equals h plus or minus a by e. Similarly, if I want to find the equation of major axis, in case of the standard form, equation of major axis is y equal to 0 and equation of minor axis is x equals 0. So in order to obtain the equation of major axis, I clearly see this to be along x-axis where y is 0, therefore the capital Y equal to 0. That implies y minus k equal to 0, and that implies y equal to k. So the major axis is a line which is parallel to y-axis, x-axis, and a distance of k units from here. So this will be k units from the x-axis and parallel to x-axis. So y equal to k is the equation of major axis for the new transformed equation. X minus h whole square by a square plus y minus k whole square by b square equal to 1. Similarly, equation of minor axis, which is x equal to 0, is with capital X equal to 0. That implies y equals x minus h equal to 0. That implies x equal to h is the equation of minor axis, which is a line which is parallel to y-axis and a distance of h units from y-axis, is how we understand the equation of minor axis for the transformed equation of ellipse. Therefore, for the ellipse, x minus h whole square by a square plus y minus k whole square by b square equal to 1. For a greater than b, we have b square equals a square into 1 minus e square, which doesn't change for any transformed equation. This is fixed. And for this, the length of major axis and minor axis are also fixed, where the transformed equation has the shape with directrix L and L dash, and this is the center, this is the foci A dash, Z dash, B dash, and how we get each of. So here the center of the transformed equation is HK. The focus is h plus a comma 0, and s dash is h minus a comma 0, and this will be a0, which changes to x minus h. So h plus a comma k and h minus a comma k is what we get. Now here b is 0b, therefore 0 in the sense it comes as h, and b, which is y minus k equals to b, gives us k plus b, and here this is h and k minus b for b and b dash, and s dash. Now my z is a by e comma 0, so x minus h is a by e, so h plus a by e comma k, and h minus a by e comma k is what I get for z dash. And equation of the directrix, which is x equal to a by e, is x equals h plus a by e, which is the x coordinate of z, and this is x equals h minus a by e, which is the x coordinate of this, is how we get the center, the foci, the directrices, and the endpoints of major and minor axis. Is how we get as the transformed equation of ellipse for the standard form x squared by a squared plus y squared by b squared equal to 1 with a greater than b. Now let's take the case of a less than b. So in this case 2 of a less than b, I have my ellipse which goes like this, Now in this case of an ellipse where I have the center as origin and my focus S and S dash, which are given by 0, B and 0 minus B, and this being A, which is A0, and A dash, which is minus A0, and B, which is given by 0B, and B dash, which is 0 minus B. I have the directrix which are given by the equation y equals b by e and y equals minus b by e, so that my z is 0 b by e and my z dash is 0 minus b by e. So using this, let's see what will be the transformed equation of this ellipse x squared by a squared plus y squared by b squared equal to 1 with a less than b. So in this case of transformed equation, I get the new transformed equation of ellipse with center being hk, and for the ellipse x minus h whole square by a square plus y minus k whole square by b square equal to 1 with a less than b. So let's see what will be each of the focus, the directrix, etc. Now as I have this 0b, my x minus h equal to 0 reduces to this, and y minus k is k plus be, and this would be h and k minus be, which I get for the focus, and then this is a and a dash, which gets transformed to a plus h and k, and h minus a comma k, and this would be b and b dash. As I see here 0b, so x minus h, which gives h, y minus k, which would give k plus b, and this would be h k minus b, and the directrix which is given by y equal to b by e implies y minus k, that is y equals k plus b by e, and y minus k equal to this implies y is k minus b by e. This is how I see each of the properties getting transformed from this standard form to the transformed equation of ellipse. Similarly, my z, which is given by the coordinate 0, which is h, and k plus b by e, and here my z dash which is h and k minus b by a, is strictly obtained from here. But length of major axis is 2b and length of minor axis is 2a, which remains the same. So equation of ellipse in the transformed form is given by this. Is how we understand the ellipse formulae using the standard form of ellipse.